Now let's do question 2 of exercise 1. (2a) given 2x squared minus 6x plus 4 equals 0. Method 1. Recall x equals minus b plus or minus the square root of b squared minus 4ac over 2a. Clearly, a equals 2, b equals minus 6, and c equals 4. Substituting for a, b, and c in the formula, we have x equals 6 plus or minus the square root of minus 6 all squared minus 4 into 2 into 4 all over 2 into 2. Implies x equals 6 plus or minus the square root of 36 minus 32, which is 4 all over 4. This implies alpha is equal to 6 plus 2 over 4, which is equal to 2. And beta is equal to 6 minus 2 over 4, which is equal to 1. And this implies x minus 2 into x minus into x minus 1. equals 0. And that is the solution. Method 2. Two x squared minus 6x plus 4 equals 0 implies x squared minus 3x plus 2 equals 0. Now we look for two numbers which when added will give us minus 3 and when multiplied will give us 2. Those two numbers will be minus 1 and minus 2. So we now see minus 1 minus 2. Minus 1 times minus 2 will give us 2. Minus 1 plus minus 2 will give us minus 3. So this implies this relationship becomes x squared minus x minus 2x plus 2 equals 0. This is a plus, not a cross, not an x. This is supposed to be plus. Plus 2 equals 0. Now we put these brackets in and bracket this out, which implies x into x minus 1 minus 2 into, this is plus minus, x minus 1 equals 0, which leads us to x minus 2 into x minus 1 equals 0. And the solution is complete. This is plus minus 2. So that's the factor method. Using factorization to factorize the equation directly other than go through the formula. It's a more elegant way of factorizing the quadratic equation. So given this equation, 2x squared minus 6x plus 4 equals 0. Using method 1, we recall the almighty quadratic formula. X equals minus 4 plus or minus the square root of b squared minus 4 plus or minus the square root of b squared minus 4ac over 2a. Clearly, a equals 2, b equals minus 6, and c equals 4. Substituting for a, b, and c in the formula, we have x equals 6 plus or minus the square root of minus 6 whole squared minus 4 into 2 into 4 all over 2 into 2. Minus 6 squared is 36. 4 into 2 into 4 is 32. And the difference is 4. So we now have x equals 6 plus or minus the square root of 4 all over 4. Which gives us alpha is equal to 6 plus 2 over 4, which is equal to 2. And beta is equal to 6 minus 2 over 4, which is equal to 1. And clearly the equation becomes x minus 2 into x minus 1 equals 0. Method 2, we just factorize. We look at the sum of roots. Here we look for a number, for two numbers, which when added will give us minus 3, and which when multiplied will give us 2. Clearly these numbers are minus 1 and minus 2. So we express this relationship, the equation, in this form: x squared minus x plus minus 2x plus 2, and we bracket them. So if we bracket them, like terms together, this x comes out, there becomes x minus 1, and this becomes minus 2 comes out, this becomes x minus 1. X minus 1 is common to both, so bring out x minus 1, and we'll have x minus 2, and the result is complete. Let me give you room for notes to be taken down. 2 minutes, please. Now we have to go to question 2b. In question 2b, we are given x squared plus 8x plus 15 equals 0. We know that a equals, using method 1, we recall x equals minus b plus or minus the square root of b squared minus 4ac over 2a. Clearly, in this case, a equals 1, b equals 8, and c equals 15. Substituting for a, b, and c in the equation, we have minus 8, sorry, b is equal to minus 8, please take that back. B is equal to minus 8, b is equal to 8, sorry, minus 8 plus or minus the square root of 8 squared minus 4 into 1 into 15 all over 2 into 1. This gives us x equals 8 plus or minus the square root of 4 over 2, which implies alpha is equal to 8 plus 2 over 2, which is equal to 5, and beta is equal to 8 minus 2 over 2, which is equal to 3. So we now see that our equation becomes x minus 5 into x minus 3 equals 0. Now using method 2, which is the factorization method, we are given x squared plus 8x plus 15 equals 0. Now we look for two numbers which when added will give you the number 8, and when multiplied will give you the number 15. Clearly these two numbers are 3 and 5. 3 and 5. So now if we express the above equation in the form x squared plus 3x plus 5x plus 15 equals 0, and we try to factorize, we'll have x into x plus 3 plus 5 into x plus 3 equals 0, which results in x plus 3 into x plus 3 into x plus 5 equals 0, and the proof is complete. Oh, there's an error here. Please look at this. There's an error here. Here is supposed to be minus 8 plus or minus the root of 4, which is minus 8 plus 2. Minus 8 plus 2 is supposed to be minus 6 over 3. Minus 8 plus 2 is minus 6 divided by 2 will give us minus 3 here. Minus 8 minus 2 will be minus 10 divided by 2 will give us minus 5. So this gives us minus 5 here. It's always good to check. So, and our result is consistent here. Please make these corrections. Let me take it all over so you understand. Given the equation x squared plus 8x plus 15 equals 0, we can use method 1, that's the formula method, to determine the roots before factorizing. So recall the formula: x equals minus b plus or minus the root of b squared minus 4ac over 2a. Clearly, a equals 1, b equals 8, and c equals 15. Substituting for a, b, and c in the formula, we have x equals minus 8 plus or minus the square root of 8 squared minus 4 into 15 into 1 all over 2, which implies x equals minus 8 plus or minus the square root of 4 over 2, implying alpha equals minus 8 plus 2 over 2, which is equal to minus 3, and beta equals minus 8 minus 2 over 2, which is minus 5. And plugging this in, we'll see that the factorized form of the equation is x plus 5 into x plus 3, or the other way around is still okay. Okay, now using the method of factorization, we look for two numbers which when added will give us 8, and when multiplied will give us 15. So in this case, 3 and 5 are the two numbers. So we plug it into the equation, we have x squared plus 3x plus 5x plus 15 equals 0. Now if we try to factorize, we'll see that x into x plus 5 plus 5 into x plus 3, 5 into x plus 3 equals 0, which results in x plus 3 into x plus 5 equals 0, which is consistent with the formula. I'll give you time to copy your notes. 2 minutes, please. Okay, time is up. Next question. Solution to question 2C. Solution to question 2C. Given x squared minus 12x plus 36 equals 0. Method 1. Recall x equals minus b plus or minus the square root of b squared minus 4 is all over 2a. Clearly, a equals 1. B equals minus 12. There's the next inside here, please. And C equals 36. Substituting. For A, B, and C in the formula, we have x equals 12 plus or minus the square root of minus 12 all squared minus 4 into 1 into 36 all over 2 into 1. This implies x equals 12 plus or minus the square root of 144 minus 144 all over 2, implying alpha equals beta equals 12 over 2, which is equal to 6. and we plug in this in our factor equation. This will mean that x minus 6 all squared equals 0. If we use method 2, factoring directly or factorizing directly instead of using the formula, given x squared minus 12x plus 36 equals 0. We look for two numbers which when added will give us minus 12. These two numbers are minus 6 and minus 6. Minus 6 and minus 6. So if we slot this into the above equation, we'll have x squared minus 6x minus 6x plus 36 equals 0, which implies x into x minus 6 minus 6 into x minus 6 equals 0, which results in x minus 6 into x minus 6 equals 0. Implying x minus 6 all squared equals 0. So we see here that given this equation, x squared minus 12x plus 36 equals 0. In method 1, using the formula, for those who may find the factorization method complicated, you recall x equals minus b plus or minus the square root of b squared minus 4ac over 2a. Clearly, a equals 1, b equals minus 12, c equals 36. Substituting for a, b, and c in the formula, we have x equals 12 plus or minus the square root of minus 12 all squared minus 4 into 1 into 36 all over 2 into 1, which implies x equals 12 plus or minus 144 minus 144 all over 2, implying alpha equals beta equals 12 over 2, which is equal to 6. And now our equation becomes x minus 6 all squared equals 0. Now using method 2, x squared minus 12x plus 36 equals 0. We look for two numbers which when added will give us minus 12 and when multiplied will give us 36. And these two numbers are minus 6 and 6. Slotting that in this equation becomes x squared minus 6x minus 6x plus 36 equals 0. We can now factor. Factorizing, we see that x comes out here and we have x minus 6. Minus 6 comes out here, we have x minus 6. We see that this is x minus 6 into x minus 6. And that gives us x minus 6 all squared. So let me give you time to take down some notes. 2 minutes, please. Okay. Now we'll do something different. Staying on the theory of quadratics. Section 1-2. Use of the discriminant to ascertain the existence of railroads. Use of the discriminant. Given a quadratic equation ax squared plus bx plus c equals 0. The expression b squared minus 4ac is the discriminant. Of the equation. Case I. Well, b squared minus 4ac equals 0. When b squared minus 4ac equals 0, the equation has repeated real roots. This means that alpha equals beta. 2. Well, b squared minus 4ac is less than 0. This means that the equation has complex or imaginary roots. Well, b squared minus 4ac is greater than 0. The equation has two distinct real roots. That is, alpha is different from beta, where alpha and beta are real numbers. So that's the significance of the discriminant. It aids you in identifying whether a quadratic equation has real or imaginary roots. We'll end our lectures here today. Tomorrow we'll do some examples, then proceed with the next section of the chapter. So I will just run this down for you to understand. Use of the discriminant. Use of the discriminant. Let's correct this. Of the discriminant. Given the quadratic equation ax squared plus bx plus c equals 0, the expression b squared minus 4ac is the discriminant of the equation. When b squared minus 4ac is equal to 0, the equation has repeated real roots. That is, alpha and beta are the same, or alpha equals beta, where alpha and beta are real numbers. When b squared minus 4ac is less than 0, the equation has complex or imaginary roots. Complex or imaginary roots. When b squared minus 4ac is greater than 0, the equation has two distinct real roots. Two distinct real roots. That is, alpha is different from beta, where alpha and beta are real numbers. So that's that for today. Come back cheerfully tomorrow.